Okay, today we start section 4.2. It's titled the unit circle. All right, so I can evaluate trig functions using the unit circle. So we got to figure out what that means. Here's the definition of a unit circle. Why don't you add this up here? The unit circle means a circle that is centered at the origin. Okay, so the center of that circle is going to be smack dab right lined up with the origin in the coordinate plane, and it will also have a radius of 1. It has those two conditions. Okay. All right, that'll be our main focus today because there's a lot of definitions we have to establish. It takes a little while just to get through that first learning target today. Okay, so what I want you to do is I'm going to demonstrate these definitions that we're going to be using quite a bit through chapter 4. All right, why don't you start by just drawing an angle, somewhere around, doesn't matter, 45, 50 degrees. Just throw that angle in the first quadrant. Okay, now we're going to call this point that the terminal side and the unit circle coincide with, let's just call this point xy. Okay, notice this is the unit circle, though, by the way. It's centered at the origin, and you can tell it's a radius of 1 because this coordinate is 1, 0, and that's 0, 1. It's all 1 unit away from the center. All right, so what I'm going to do is create a little right triangle setting so that we can establish some definitions that'll work for the unit circle. So I'm going to drop this side down, okay, to create a little right triangle. So if this is a right triangle, naturally, whatever distance I went over this way to get up to x, just say I went over 0.6 and then up 0.8. Well, that means this side is 0.6. So I'm going to call this side of the triangle now x, and then this side y. And then naturally, this is the radius of this unit circle, which is 1 still, but let's just call this r. Sometimes the radius might change. Not so much in this section, but you'll see in other sections where the radius will change. All right, and let's just call, well, the definitions, they use t. Sometimes we call it theta. It doesn't really matter. It's just a variable. So sine of angle t or sine of angle theta is equal to what? So let's just call this angle inside here, nestled in here, t or theta, okay? Okay, now back in Algebra 2 or maybe even geometry, you were taught some really basic right triangle trig function rules. Sohcahtoa is a way to remember some of those. We'll review those in detail in section 4.3. In this section, I'm just going to use them to establish some definitions. So for example, I'm not going to write them all right here, but like sine of an angle is equal to opposite over hypotenuse. Okay, so if I'm using that old right triangle trig definition, what is opposite of theta or angle t? Well, opposite's across. So it's y, and then what's the hypotenuse of this triangle I created? R. Okay, so sine of angle t, when using the unit circle, will always just be the y coordinate divided by the radius. Write that down right over here. Okay, so we're establishing some definitions that will work as long as I have a coordinate on the unit circle, and I know the radius, which is usually going to be 1 in this section. Okay. All right, let's move on to cosine before we get to the reciprocal functions. So cosine is adjacent over hypotenuse. So let's look at the triangle. The adjacent side means next to it, but not the hypotenuse. So it's x over r. Okay, so write that in for our cosine of angle t definition. Okay, and then tangent, if you recall, is that Sohcahtoa, the last part, O over A, opposites over adjacent. So that would be y over x. Okay, so make sure you understand what we just found is that we don't need to create a right triangle every time now. If I have the coordinate that it passes through, I can now just take the y value and divide it by x, and I don't have to create this right triangle because we reestablished some definitions that work in the coordinate plane for the unit circle. Okay, now these are called the reciprocal functions, and you may never have seen these before. but they are just that, the reciprocals. Cosecant of angle t, and that's how you say the word. That's what it's spelled out here, but this is the abbreviation for cosecant. It's always the reciprocal of sine every time. That's how I put them right next to each other. Okay, so the reciprocal just means we flip this over, right? Exchange spots with the numerator and denominator. This will be r over y. Now, sometimes in the coordinate plane, y is 0. So just add this down here. Y cannot equal 0, otherwise it's undefined. We didn't have that for sine because sine, the denominator is r. And if you don't have a radius, then you don't have an angle. You don't have a problem. So you don't have to worry about that. Okay, secants, abbreviated SEC. This is always going to be the reciprocal of cosine. Okay, so it's going to be r over x, where x cannot equal 0. And then tangent and cotangent, these are also reciprocals of each other. So if tangent is y over x, cotangent is going to be x over y. Both of these actually have restrictions. I didn't put it in there before, but the y cannot equal 0 here, and x cannot equal 0 here, okay? All right, so those are the 6 trig functions we have to get used to, eventually commit to memory before the quiz, okay? All right, so here we go. Let's go ahead and apply these to this example 1 down here. A point xy is shown on the unit circle corresponding to a real number t, so some angle t. Find the values of the trig functions at that angle t. Okay. All right, so I do not need to now create a triangle and use Sohcahtoa. In some problems, it would be impossible to do anyways, if they lie like in between quadrants. All right, so just trust me on that. All we need is 3 things. We need the x-coordinate, we need the y-coordinate, and we need the radius. Do we have all those things? Yes, we do. It told us this is the unit circle. So immediately we need to realize that the radius is 1. Okay, this is the x value, this is the y value. We have everything we need to go ahead and answer the question now. Now it's just a matter of doing the algebra and the math for it. So sine of angle t, remember sine is y over r. I'm going to try to leave space for the answer there, so I'll just put this here. Sine is y over r. So what's the y value? The y value is 5/13. So I say 5/13 divided by r. And the radius, since it's the unit circle, is 1. Okay, so the answer simplifies to 5/13. That's the answer to sine, right? I guess I don't need to circle all 6, but oh well, I already did. Okay, now remember, sine and cosecant are reciprocals. So you don't need to start over again and do r over y. If you have this, just flip it over. Okay, it's 13/5 for cosecant. Okay, cosine, by definition, is x over r. Okay, cosine is x over r. So what's that going to look like? Well, the x value is 12/13 divided by the radius of 1. So it ends up just being the x value, which is 12/13. Okay, secant's the reciprocal, so we just flip that over and you get 13/12. Okay, tangents. So when some tangent cotangent sometimes get a little bit messier. So remember, this is always y over x from that definition I put up there. So y over x. Y was 5/13 from the coordinate. And then the x value was 12/13. All right, so what do we do when we divide by a fraction? We multiply by the reciprocal of what we're dividing by. So 5/13 is now multiplied by 13/12. Okay, so these cross reduce, and I get 5/12 for tangent. Cotangent, I could start over again and do y over x and then do all that math, or I could just flip this fraction over right there. Keep it simple. Just do that. Okay, so those are my 6 answers. Okay, 2 should go pretty quick now that you've seen this happen, and some of the math is pretty easy for some of these. So try number 2, and then I'll help you through a little bit of 3. Might not finish all 3 because I want to get to the next page as well. Okay, so go ahead and give yourself about 2 minutes to try number 2. Okay, here's your feedback on 2. Here they are. Remember, sine is y over r. Some students get sine and cosine mixed up. You know, they do x over r here. Think of the sound sine makes. That's a little trick that I've given students before, and it kind of makes sense, right? Sine, you can almost spell with a y, and it makes sense, right? In terms of the way you pronounce it, is what I'm talking about. So that's a good way to remember that sine is the y over r, not the x over r, if that helps. If not, then I guess make a flashcard and just work on it. All right, so there's your answers. Tangent, the messy one, y over x, multiplied by the reciprocal. These 5's cross reduce, so that's how we get the negative 4/3 for tangent. Okay, let me kind of take you through 3. We'll kind of do this part together. They added some radicals to these coordinates. So sine is the y over r. So my y coordinate is here, x coordinate's here, radius of 1. So this divided by 1 is just negative square root of 5 over 3. Okay? Now cosecant, when we flip that over, we're going to have a radical in the denominator. So it is expected that you rationalize these. So I'm going to do the work below. So if I flip this over, we get 3 over square root of 5, and it's negative. Okay, so in geometry a long time ago, you were expected to multiply by the square root that's in the denominator to the top and bottom. It's a form of 1. It's how we rationalize this and get rid of that radical. Because on the bottom, square root of 5 times square root of 5 is square root of 25. Square root of 25 is 5. So the radical is gone now. That's the whole idea. Up top, 3 times the square root of 5 is what we get. Nothing to do there, and then it's negative. So there's the answer. Negative 3 square root of 5 over 5. We'll just circle that. Okay? All right. Cosine and secant is pretty straightforward. X over r, so the x is negative 2/3 divided by 1, so that gives us negative 2/3 right away. And then secant's negative 3/2. Okay, tangents. Y over x, so I've got to take this fraction divided by that fraction. There's be a lot of dividing by fractions in trigonometry. You got to just get used to the math. So I have this over the negative 2/3. Okay, well, I have a negative divided by negative, so I know that's going to be positive right away. I'm just not going to write the negatives anymore. But I'm going to take the square root of 5 over 3 and multiply it by the reciprocal, 3 over 2. 3's cross reduced to just 1's, and then I kind of have my answer for tangent now. It's just square root of 5 on top, 2 on the bottom. Okay, so there's that. Okay, for cotangent, though, we flip this over. We've got to rationalize it. So I'm going to pause here for 30 seconds and have you guys work on rationalizing that. So flip it over, get the radical out of the denominator. Okay, give it a shot. Okay, here's your answer for cotangent. Multiply by square root of 5 over square root of 5. Okay, let's go to the next page.